So, welcome to the CP213 review session number 5. My name is Mila, and I'm here today with Noah and Tobin, and we're going to walk you through exception handling, interfaces, and inner classes. So, let's move on to the next slide. Sorry for starting a smidge late. And if there was any confusion for starting at 7 or 7:30, but yeah, we are starting 7:30. So sorry about that if there was any confusion there. So yeah, let's move on to the next slide. So if I could just if you guys could just take this moment to sign in, just please scan the QR code and fill out the type form. I'm gonna give you just a couple of moments here. So yeah. How is everyone doing in the chat? Drop how you're feeling. Are you excited that, I don't know, school is almost done, the semester's almost done, it's almost winter break? I don't see any text, so I guess it's a rough crowd today, but that's okay. Hope you guys are doing well regardless. So I think we can head over to the next slide. I think that's enough time. I feel like you guys have signed in by now. So yeah, let's move on to the next slide. So, okay, so some upcoming events. We've got obviously our next review session. It's going to be the final exam review. It's happening Wednesday, November 29th, so save the date. As always, we're going to have free food. Free food. There's going to be prizes, so if top 3 Kahoot winners, as always, will get prizes. So, come out to that. Great way to win something and test yourself at the same time. So it's a win-win. And of course, you can always come socialize with some upper years, maybe get some, input, ask some questions on anything that is confusing to you or anything that you need some refreshing up on. So yeah. Let's move on to the next slide. All right, so as always, so useful links and follow along resources. Like I said, we're almost at the end of the semester, so I think it's kind of that, one final push really. So hold on. We've got the Math and Stats Learning Support Center, and of course, various resources like coding sandboxes to help you out. Math and Stats, great way to go, a great place to go, for drop-in sessions, really direct kind of the homework. It's directed homework sessions, and they can give you any extra help, and it's for lower CS courses, so take advantage of it while you can. And then coding sandboxes, as always. Replit, I think, is most people's personal favorite. It's got almost, I think, every language on there, so great resource to check out, as well as CodePen.io. So yeah, let's move on to the next slide. So yeah, again, like I said, we're nearing the end of the semester, so as always, make sure to check in with yourself. University can be stressful. Obviously, final exams can be stressful. So yeah, some other resources as well: SafeHawk app, Student Wellness Center, Delton Gleb Counseling Center. So always don't be afraid to reach out. If you're ever feeling uncomfortable or something's going on, right? So yeah. So I think that kind of concludes our little intro. So let's get into the actual, content covered in this review session. So, all right. So what is exception handling? So by definition, exception handling is a way to deal with unexpected problems that might happen while the program is still running. So it's like saying if something goes wrong, do this instead of crashing, right? There's a fence, for example. You can go around the fence instead of being stopped by the fence, right? It's kind of like just going around sort of thing. So for example, we have a little clip art image here, right? So in the first part, a girl is watching a video on YouTube on the computer. Our exception here, Wi-Fi cuts out, right? So obviously this interrupts the watching of the video due to the internet disconnecting suddenly. So yeah, video stops, we can't watch it anymore. Second, little real world example. So you got a car, the car is punctured, so that's our exception. But we are handling that exception by repairing the puncture. So, driving, shard of glass goes into car tire, you stop on the side of the road, change the tire, continue driving, right? Exception has been handled. Maybe in the first example, Wi-Fi cut out, let's say, turn on your hotspot, continue watching video, right? So it's just a way to go around a problem instead of, being stumped. So, yeah, so it helps make programs more robust and prevents them from unexpectedly stopping. And this is obviously an extremely, useful tool to implement into any program that you are making. So yeah, I think that's kind of the gist of what exception handling is. Are there any questions about this? Maybe I went a bit too fast on something. Drop them down in the chat. I'll give you guys just a couple of seconds. Three, two, one. Okay, I don't think there's any questions as of now, so let's head over to the next slide. All right, so very important. So our try, throw, catch mechanism. So this is the basic way of handling exceptions in Java. So we've got, in this slide in particular, we're just going to talk about the try block. In the next slides, Tobin's going to walk you through some of the others, so the catch, throw, finally, right? So the try block is like a protective shield around a piece of code where something unexpected might happen. It's where we say, try to do this without any errors, right? So we've got below, we have our code. So try is our keyword. So what's going on here? So we've got code right below the try keyword inside the curly brackets, and that's gonna be the code that may or may not cause an exception, right? So we're gonna test it out, right? We're gonna see, okay, if there is an exception, we're gonna catch it, and we're gonna deal with it in a, in a correct manner, versus if there isn't an exception, the program will continue to flow as it should. So here we have some code, and just by looking at this, I think we can all tell this will cause an arithmetic exception, right? Division by 0. You're right, because it's like undefined. So the program doesn't really know what to do when it comes across, so it's going to throw an exception. So I think this is like a little fun fact. Integer division by 0 produces an arithmetic exception. If you do floating point division in Java, produces a runtime error. And I'm like 99% sure, but you can always, of course, search this up. This is caused by memory representation. So for integers, there's actually no bit pattern that can be used to store the result of the operation, while floating point numbers have values like NaN or infinity. So just a little fun fact for you guys. You can definitely go and fact check me on that. But yeah, so we've got error versus exception. Key thing to note, I guess, error can occur at compile and runtime, and it will stop the program. Exceptions occur at runtime, and they can be dealt with accordingly with exception handling. So I think obviously using exception handling is a great way to make that program robust, like we said before, make it more functional. So yeah, it's a very important concept. You guys will be seeing more of it. I don't know for sure if you guys had I think you already had your lab this week on it. But yeah, you're going to be seeing it a lot. So yeah, I think that covers, my part of the slides. I'm going to pass it over to Tobin, but just quickly before I do that, are there any questions on specifically the try block in the try, throw, catch mechanism? I'll give you guys a couple of seconds. Just as before, drop them down in the chat. Anything is concerning you? All right, 3, 2, 1. Okay, no questions, I guess. So hand I'm gonna hand the mic over to Tobin, and he's gonna walk you through the rest of the exception handling slides.
All right, so thank you, Mila. So now talking about the second portion of the try, throw, catch, which is a catch block. And the catch block is like a safety net that catches and handles the errors that occurs in the try block. It's where we specify what to do if something goes wrong. So for example, when we're looking at our try block, right, we can see that we set a result to 10 divided by 0. And in mathematical equations, you can divide 10 divided by 0 because it causes a math error. And so when this happens, we proceed to the catch block that matches the error itself, which is arithmetic exception. And basically from here, since it catches the error that 10 cannot be divided by 0, it prints the statement that says error cannot be divided by 0. So moving on now to the next slide. All right, so now talking about the third portion of the try, throw, catch mechanism, which is the throw. So sometimes we want to tell the program that something unexpected has happened. We throw an exception to signal this, and it'll be caught and handled elsewhere in the code. So for example, we have this method that's basically void check temperature, and a parameter is an integer that's called temperature, and it throws an illegal argument exception. So this happens, this error basically occurs when we're passing on a variable that's illegal or invalid. So in this case, if you look at the first line inside this method, we can see that if temperature is greater than 100, then it's going to throw an exception. And to throw an exception, you need to use two words. You need to use throw, and you also need to use the word new in order to throw an exception. So in this case, we're throwing an illegal argument exception, which is too hot. And the reason why this is because when it comes to temperature in Celsius, it cannot be greater than 100. So moving on to the next slide. All right, so pretty much inside this code portion example, we have this class that's called exception example. And inside here, we have our main method. And inside this main method, we first have the try block. And inside this try block, we're setting an integer result. We're setting that to, we're setting this to basically calling the divide method. And we're setting the parameters, the two numbers, 10 and 0. Once we do that, the divide function is going to be called. And inside this divide method, we have two parameters, numerator and the denominator. And we're checking if the denominator is equal to 0. An exception called arithmetic exception is going to be thrown, and which is true in this case because the denominator is 0. And this exception is cannot divide by 0. So once this happens, the normal flow of control for this code is halted. And what happens is the program is going to continue to the first catch block that matches this type of error. So because this error is an arithmetic exception, it's going to go to the catch block in the main method, which is called catch arithmetic exception E. And inside here, it's going to print the error. Error division by 0 is not allowed. So moving on to the next slide. All right, so lastly, I'm going to talk about the finally block. So in Java, a finally block is a piece of code that you can add after a try and catch block. It contains code that will always be executed regardless of whether an exception has occurred or not. So we're taking a look at this example. We have a class that's called finally example, and inside our main method, we have the try block, and inside here, we're printing trying something risky. Then we're setting the variable result to 10 divided by 0. But this is going to cause an exception, as I mentioned before, because in math, you cannot divide something by 0. So what happens from here is the next line is not going to be executed because the process of control is going to be halted, and it's going to go to the first catch block that matches this type of error. So because this is an arithmetic exception, it's going to go inside the catch block, and it's going to print error, division by 0 is not allowed. Afterwards, we're going to have our finally block, and this portion is going to continue regardless if there's an error or not. So the line is going to be printed that says this code always runs no matter what. Now you can move on to the next slide, Noah. So does anyone have any questions? So I'm just taking a look at the chat. Seems to be no questions. So I'm going to pass it on to Noah, who's going to talk about the inner classes.
Hello. So yeah, we're going to do interfaces and then inner classes after that. So interfaces. So the idea of an interface, it's basically to promote like code reusability and to save time from a programmer's perspective because it allows for you to use code that is basically predefined and then you can just implement it and it makes you not have to do a lot of the work because a lot of that work is done for you beforehand with the interface definition. So interfaces. Interfaces are like templates of classes which you can implement in your own class definitions, and this helps save the programmer time and provides an opportunity for code reusability. And interfaces just need to have their methods defined with a name and return type. The actual contents of the method code can be written later. And this is why interfaces are an extremely helpful blueprint for coding. Because if you want to implement, say, two different approaches to the same idea for a class, then you could just implement that interface and you already have the method definitions made for you, and all you'd have to do in these two separate class implementations is just filling in how you define these methods for these two separate classes. So that's the key advantage of an interface. And so here's a code example of a Java interface. So here we have interface shape, and this is the definition here. We have two methods, calculate area and display. And this is how you implement the interface. So here we have a class circle, which implements the shape interface, and we're giving it an instance variable, which is double radius. And then we have a constructor here, which takes the radius as a parameter and says that this dot radius is the radius. And then here we have, we're overriding these two methods that we defined in the interface, and we're doing calculate area, which returns math.pi times radius, because pi r squared to get the radius of a circle. And then for display, we override again, and then we do locally display, and then it displays this is a circle with radius, and it just prints it to standard output. So that's an example of an interface, and then the implementation of an interface into a class definition. So yeah, does anyone have any questions by chance? And Tobin, could you read the chat and pull up the questions for me? If there are any questions, or...
Yeah, I can do that right now. It does not seem like there's any questions.
Okay. So now we'll go on to inner classes. So inner classes are just classes that are defined within other classes, and the class that includes the inner class is called an outer class. And there's no particular location where the definition of the inner class or multiple inner classes must be within the outer class. However, if you put the inner class like at the top or the bottom of the outer class, it means that it will be easier to find. So basically, if you're going to put inner classes in your outer classes, it's discouraged for you to sort of put them in the middle of the class, scattered between other methods. If you put that inner class at the top or bottom, it'll be easy for navigating, and that just saves time for like other people if you're going to work on a project with other people, for example. But yeah, so that's the advantage of inner classes. And here's an example. So this is the outer, and then we have here an outer variable, and then this is the inner class called inner mouth, and then we square it, which returns the square of the outer variable times the outer variable, and then returns outer variable times outer variable as an integer, which is in square, and then we have divided by 2, which is return outer variable divided by 2.0, division resulting in a double. And so we have this inner class defined here within this outer class definition, and it's defined at the end, so it's pretty easy of the class. It's pretty easy to spot the inner class within the outer class. Obviously, the outer class is very small, so anything in the outer class is easy to spot. But like this is the advantage of putting the inner class at the end. But does anybody have any questions? And Tobin would ask you once again to pull up the chat just to make sure.
Nothing. No, I don't see anything.
Okay. So please fill out this event survey we have here. Scan the QR code, please, for that.
And yeah, I think that concludes our review session. So as always, thank you so much, guys, for coming out and tuning in. We hope you learned something or got to refresh on a concept that you were unsure about before. This was our last online bi-weekly review session. So like I said, the next one will be in person, and it will be on November 29th. So, come out. Free food. We know you guys love free food. So yeah, you'll get a bunch of that. And, as always, there's prizes, and yeah, it'll be a great time. It's going to be our last review session for the year. Actually, well, that's excluding 104, but you guys obviously are not taking 104. You've already done that. So yeah, come out to that. And yeah, it was a pleasure to host this review session. So we'll see you next time. Bye-bye.